If we have a set of vectors, let's say v1, v2 till vp, then a linear combination of these vectors will be c1 v1 plus c2 v2 up to cp vp. So this is a linear combination of these vectors. Now let's take two vectors in this xy plane. This is u and this is v. So u is 2 2 and v is -1 2. Let's find out one linear combination of these two vectors. So that will be c1 u plus c2 v. Let's take c1 is 2 and c2 is -1. So the linear combination will be 2 times 2 2 plus -1 times -1 2. That is 4 4 plus 1 minus 2, which is 5 2. Let's try to draw this in this xy plane. We are scaling the first vector 2 times. So this is our scaled first vector. Then we are scaling the second vector -1 times, means we are just flipping this second vector, and then we are adding this 2 vector. So we just move the second vector and place it at the top of the first vector. So our resultant linear combination is this vector. So you can take any scalars and create different combinations of this set of vectors. Next comes the span of vectors. The span of a set of vectors is the set of all possible linear combinations of those vectors. So span of v1 v2 till vp contains all vectors of the form c1 v1 plus c2 v2 till cp vp, where c1 c2 till cp, these are all scalar numbers. So basically we are taking a set of vectors, we are scaling the vectors arbitrarily using different scalars, different real numbers, and then we are adding them up to get a linear combination, and the span is basically the set of all possible such linear combinations. Now what is the span of a single vector? Let's take a single vector. We can scale the vector in the positive and the negative direction, but will be in the same line only, right? So the span of a single vector will be a line, but if this vector is a zero vector, then the span of this zero vector is the zero vector itself. Span of two vectors. So consider the xy plane we have, and let's take two vectors. What is the span of these two vectors? We can scale the vectors and add them up to get new vectors. So this is one linear combination of these two vectors. Let's take one more linear combination. We are just flipping the first vector, and let's take the scaled version of the second vector and let's add this 2, then we get this vector, right? In this way we can scale the two vectors with arbitrary scalars and we'll get all the points in this xy plane. So if we take any two vectors in this plane, the span of this two vector will be this R2 plane. There will be one exception if two vector falls on the same line. If the first vector is this one and the second vector is this one, then both fall on the same line, right? So if we just take the scalar multiplication of these two vectors and add them up to get some linear combination, then the linear combination also will fall on this line only. So in that case, the span of these two vectors will be just a line. But in other case, if we just take randomly two vectors on this xy plane, the span of those two vectors will be the two-dimensional plane. Similarly, if we just see in this three-dimensional space, if we take any x plane, like here we are showing the xy plane, yz plane and xz plane. So in any plane, if we just take two vector and take the span of these two vectors, that will be the whole plane. Let's see in the three-dimensional plane. So in the three-dimensional plane, let's take some other plane, not just the xy and xy, yz or xz plane, any plane that is going through the origin. So this is one plane we have taken, and let's take two vector on that plane. If we take linear combinations of these two vectors, then we can see we can get if we take linear combination of these two vectors, any two vectors, will remain on this plane only. Let's scale this one, let's scale this one, right? And then let's add this two. This will be on the same plane. Also, let's scale the first one in the opposite direction, and this is the scaled one, and then add this two, right? So this also will be on the same line. So the linear combinations of these two vectors will be on this plane. So the span of any two vectors on this plane will be this plane only, unless two vector falls on the same line or one of the vector is zero vector. If you find this video useful, please like, subscribe and let me know about your feedbacks in the comment section.